There's been a lot of talk today about big data and analytics and how all that fits into the energy industry, and now we have a whole panel that we're going to take some time to discuss that. So big data, it's a big topic. We have 50 minutes to cover it, and fortunately we have a really great panel here to hopefully be able to do that. So first of all, I'm going to do some quick introductions, and then we're going to launch into some questions, and then hopefully get some great questions from the audience. So to my left here, we have Sal DellaVilla, and he is the founder, chairman, and CEO of Strategic Power Systems. We also have Kevin Marr, who is the chief operating officer for Power Analytics. We have Tim Fairchild, who is the director of the global utilities practice at Sas. We also have Matt Zafuto, who is the executive vice president for corporate strategy and business development at Sensus. And last but not least, we have Dr. Pat Kennedy, who is the CEO of OSIsoft. So thank you so much for joining us here today, gentlemen. So to get started, I have a question that I wanted to pose to everyone here. We've talked a lot about big data. We've talked a lot about smart grid. I mean, it's really exploded in the past few years, a lot of hype and a lot of excitement around it. There are so many new things going on. But at the same time, a lot of people I've talked with have said, oh, well, this is something that we've been doing for a while, or this is just an evolution of things that have been going on for a long time. So what I wanted to hear from each of you is, if you had to pick one thing, what's really the most significant change that you've seen in big data and analytics over your career? And what, if anything, has really stayed the same or remained constant throughout the years?
I think that there's always been an interest in data, and at the end of the day, today we now have access to data that's basically at your fingertips once per second from machines.
Yeah.
But what's changed is, I think, the understanding that data really has value. I think that we all understood that you need to use data to help make business decisions. Today, I think the fundamental question is how quickly can you do that? How quickly can you take this information from the machine and make a decision that affects, the reliability of that machine, or at the end of the day, the profitability of that machine? I think that's the driving change, because we've always analyzed data. Statistics is about data analysis. It's about understanding the variability in looking at data. But I think the point is now it's so abundant, it's so at your fingertips, that's the fundamental difference.
Kevin?
Yeah, I would say that probably the single biggest change that I've seen, and I agree. I mean, you got people up here like Tim and Pat, who have been right in the middle of analytics for a long period of time, and even in our case, the things that we do on the power side. But the biggest change is, I think that there's been an increasing awareness because the community at large has kind of learned that there's huge value to the analytics that you can provide to data, and this secondary activity that's bringing more and more data in. So it's where our expectation levels have gone through the roof. Everybody is, like I say, everybody's impatient. I want it to be, hey, it worked for that company. Why can't it work for this company or this application? So, and they're right. They're right. It is changing pretty rapidly. So.
And I would just add, I think the single biggest change is just the tremendous improvement in the cost factors for both computing and also data storage. And if you think about someone like Dr. Goodnight, who has been doing this since the 60s, and just like Scott said earlier, they didn't know to call it big data in the 60s. And they didn't know to call bureau computing, cloud computing back in the 60s. But it's so delightful to see Dr. Goodnight, who's been doing this for so long, so energized about analytics, and it's because we've really democratized heavy-duty analytics because of basically commodity hardware, which you heard him describe. The one that cracked Charles up so much was Dr. Goodnight's description of compute power, and we certainly see that with data storage as well. And it's delightful that it's relatively inexpensive to store data now.
I would say that the biggest change is actually the expectations that each of us in the room and those of us around us have. And I'll say that each one of us on this panel, and I think all the rest of the panelists today, are what I would classify as digital immigrants. So we didn't grow up with text messaging and social media and Snapchat. But today's new entrants into the workforce, and we've heard a lot about higher education and the community colleges here in North Carolina. All of that new workforce, they're digital natives, and there's a different kind of expectation that's really driving a lot of the innovation around data and analytics.
Some of us started even before that, like the transistor was just developed. But the biggest change I've seen is there's no question, scale. You look at some of the applications out there, Facebook or LinkedIn, it's not all that tough to imagine building yourself a display that shows your name and address. But the scale at which they do it is what's different. To talk about 1 billion or 2 billion users and then taking all that data and inferring information from them is really, that's really the main difference.
Great. Yeah, I mean, definitely the scale, and yeah, I mean, they're just things just constantly evolving. So I think now we'll jump into some specific questions for each of our panelists and just see where the conversation takes us. And the first question I want to ask is for Pat. So Pat, I mean, we've seen a lot of opportunities with big data and analytics, but also, a lot of challenges. Things, whether it's security, privacy, network services, intelligent connected devices. And there are a lot of challenges out there with big data. And what I wanted to ask you is, how are you seeing, particularly things with sensor-based data, how is that helping utilities and the energy industry overcome some of these challenges that are facing them?
Well, part of what goes with scale is getting a larger data set. Almost invariably, your predictions are better with the more data, even if it's not really good data, having the data at all. The sensors, I think it was said in one of the earlier panels, the sensors, machines that are putting out data, these are the massive sources of data. Mm-hmm. They talked about the synchronous phaser, which puts things out in multiples of a frequency. And you say, well, that's really fast. Do we really need that kind of data in the power industry? Oh, well, only if you need to see a failure coming in the grid, because that's what that information gets for you. So really the thing that we see is we see lots and lots of data. We see data that's coming unbelievably fast. We'll hear people talk about 1 trillion data points, but then if you look at it, it's in a year. Mm-hmm. And that's 17,000 events per second. And there's existing grids today that are measuring, 10 times that. So, it's coming very, very fast. It's coming in a very different form, the form of events. And then our challenge is to take it, aggregate it, and put it to use by whoever needs it.
Yeah, definitely. Now, so we've talked a lot about scale and some of the different issues within big data and analytics. And one topic that ends up coming up a lot is predictive analytics. So we're going to predict this and be able to predict that. And there just seem to be a lot of questions around, well, what is predictive? What does that really mean? And Sal, I wanted to pose that question to you. What does it take to be predictive, and what does it even mean to be predictive?
Thank you, Christine. Being predictive for me is how fast can you look back, how quickly can you look back to make a decision that you need to make today. And when I started in this industry, and my focus is generation, power generation, typically gas turbines, combined cycles, wind turbines. The one stationary component is a blowout preventer for deep sea applications. But when I started in this career, data for me was whatever data that we could get on a gas turbine plant, almost as innuendo. We didn't have performance metrics. We didn't have data, temperatures and pressures, and we had failures. So being predictive back then was data that you had that was a month old, maybe a day old if you were lucky, or performance data that you can go when a performance engineer went out and did a test. And so you had to use that data if a failure occurred on a gas turbine to try to drive an understanding of what's going to happen to the fleet. Today, remote monitoring allows me to see a broad number of gas turbine units, and I'm seeing data once per second, once per mil, depending upon the frequency of the data set. You're still looking backwards. Data 1 second old is looking backwards. And so the question is, what do I need to do with that data to be predictive? What are the issues I need to address? So yes, you can be predictive. How reliable is that prediction going to be? So, at the end of the day, prediction is in the eyes of the beholder. If I'm studying failures, I've got an issue with generators or generator field grounds, I better have the data there that's available to me to make the business decision to determine whether a unit that has not yet had that generator failure, whether the information I have lends me to believe that the probability of that unit failing is so great, I need to tell that operator to shut that plant down. You can do all of that. And at the end of the day, it's how you transform the data for value. And just remember one thing, you're always looking back to make a prediction about tomorrow.
Great point. Any other thoughts around the predictive side, or any other things? Kevin?
Yeah, well, the only thing I agree with Salvatore. Historically, if that's a fair analogy, because it hasn't been that long, but most of the advances in some of the early analytics, even some of the stuff that Sas has done, has been deriving value from being able to characterize what was happening through a lot of data. And the more data you got, the more, and everyone began to realize that more data, concurrent with the fact, like Pat said, you got Moore's law, making it easier to get more, and the more you get, the more you want. I have a daughter, I know that. So there's a huge convergence of it. We just, the energy industry, I would argue, is just at an incredibly unusual time where all of those things are going on in a lot of places, but we happen to be in the spot where it's all coming together at the same time, and reasons that aren't obvious, that being able to predict what's going to happen so that you can, you can act on it. It makes it something that you can actionable if you can predict it. So.
Yeah, and I actually talked to Sal about this last night. Sas does a lot of work in oil and gas, and they have a lot of data, and they have some very compelling economics about predicting failure when you're talking about oil platforms, and some very interesting maintenance challenges. For instance, with electric submersible pumps that sometimes are in several thousand feet of water, and very difficult to get to, very expensive to get to, also throwing off a lot of data, and there's a very strong value case when you go predict the failure of that asset. Same challenges for electric utilities. In most cases, the assets are a lot easier to get to. You can put a wrench on them, you can put a hand on them, and we actually had a great opportunity to get an enormous amount of combustion turbine data from a customer. And the best thing was it was already in Pi. And it gives us a great opportunity to work with that customer to look through all that data from all those sensors that are in the typical combustion turbine and look for some new and interesting ways to predict failures or maintenance events.
I think that's part of what utilities have done a reasonable job with, actually, over the course of their distributing safe, reliable power. But as the complexity of their delivery model increases, predictive analytics, the problems to solve are increasingly complex as well. And that's where predictive analytics now, there are a whole lot more problem sets to come up with and then correlate all of those events together to come up with an actionable solution that wasn't in place before.
I would say just something, too, from a technical perspective. When you look at predictions, yes, the more data you have, the better it is. But we forget sometimes that one of the other things we have is all the historical data. And instances like the big Northeast blackout, I remember we first blamed Canada for that. So it turns out it wasn't their fault. But their analysis was really good compared to ours. They really went into it. But I remember them saying, oh, we'll never find the reason. That's not true, because in the power industry, you can't hide. You can stick a synchronous phaser in the plug in this auditorium and see how they're running the grid out there. So everything's all connected, and having all that forensic data and all the forensic is also equally a valid way to use the models, as well as then once you have them, to use them for prediction.
So we've talked a lot about value here. You know, what's the value of big data and of analytics? And a question for you, Kevin, is, you know, one of the 4 V's, or actually there are a lot of V's that seem to go along with big data, is just, you know, velocity, the high velocity of the information. And, you know, I think we've seen that in terms of the expectations of results and value being delivered from some of this data and analysis that's going on. So, I mean, what are utility companies and the energy industry, I mean, how are they getting value right now out of big data and analytics? And, you know, why should companies be focusing on it now?
Yeah, well, thanks, Christine. Yeah, well, a couple things. One is, I mean, you can use the Willie Sutton analogy that, you know, the reason you're not going to the bank, the reason that you're going to big data, if you're thinking about analytics, is because there's a lot of it there. So that's just like almost every panel that I listened to today had some discussion about big data. But I also think that the two, from my perspective, the two macro things that are going on that particularly affect energy and power, not just for utilities, this is for everybody and everybody in the room, in particular in a lot of the developed economies. But we've just, if you think about energy and power and how we use it and the way its ubiquitousness in our lives today, because all the technology is dependent on it, there aren't a lot of analogies in the last 50 years where there's been this kind of transitional piece. And the last time it happened, I would argue, was the telecommunications industry. So between the 80s to the 90s, which resulted in phenomenal change. That business model, the new opportunities that represented, completely shifted and changed over that time. And now we're in a situation where we have not just real-time data, but like Pat said, historical data that has the ability to recognize patterns based on a way to even for unstructured data, so that we can see things that we've never been able to see before. And then we have the other kids, pick on my daughter again, who they're very impatient. You know, they want to be, you know, in fact, I think there was an article in that Rocky Mountain Institute put out a few weeks ago, and it was exactly, you know, when will there be a Airbnb for energy? And they're absolutely right. Anybody here at this conference might not think that way, but everybody else who wants to know, you know, why is it that I have to keep doing things the way I've always done it? And it also opens up opportunities for a lot of creative, you know, the kids from NC State and everywhere else, that there are new things that they're going to be able to take advantage of, marketplaces, opportunities, the apps for this new world, and they're not going to be patient. They're not going to be patient with the way things have happened in the past. They're going to expect it to happen faster than that, and they're going to look for new areas. And if this was a group of telecommunications guys up here in 1992, who would have said, you know, that they would have even some discussion about this company called MCI, but you know, who else? I mean, none of that would even entered anybody's thought process. And I think we're seeing the same thing happen because of the way that we use and the way we work with power and energy all the time. So we're in a wonderful place. It's you know, you blink and it's going to be done. But I would argue that a year from now it'll look very different than it does now. That same question.
Yeah, I mean, definitely think it's an evolving model. And Matt, I know you've talked about and presented before on data as an asset. And do you want to talk a little bit more about that in terms of viewing the value of data and analytics?
Sure. I think it's clear after a lot of the presentations today that the utility business model is extraordinarily more complex now than it was even just a few years ago. You know, the utility value chain was previously characterized as central generation, unidirectional flow of energy, and very intermittent exchange between consumer and utility of any kind of information. And usually that information was, here's your bill, here's where to send it to. Here's where to send it. So now we've got decentralized generation, multi-directional flow of energy, and really a need to have multi-directional flows of information across the new energy value chain. So it's much more complex. That would be the first thing I would say. You know, the second thing I would say is that data in and of itself isn't in its raw form useful to the utility. And I think we actually heard a little bit about that today. So Don Bowman, I was interested to hear his remarks. He's not only a customer of mine, but he's also my energy provider. And for those of you who are curious, my water does stay hot, my beer does stay cold, so there's goodness there. But Don hasn't come up to me and said, you know what, Matt, I'd like more data. Now, what we have talked about is he would like more information and more knowledge that he can use for decision support. So if we take it from that angle, utilities at their core are great asset managers. Those assets can be substation equipment, centralized generation, now distributed generation. But if they can start to change the paradigm and think about that information or knowledge as an asset that can be exploited, and whether that's information about their asset base or about their customer franchise, all of that is useful information that then they can improve their operations, be more profitable, decrease outages, all of that. So, you know, kind of transitioning away from just raw data, and that's where companies like Sas and OSIsoft come in, and obviously Power Analytics to help them in that transformation.
Yeah, and I know with Tim, you had also talked about, you were intrigued by the quote from OSIsoft's site that talked about lowering the marginal cost of curiosity. Do you want to talk about that a little bit more in terms of the value for data?
I just would like to say that I wish I had thought of that quote. We heard it from some guys from OSIsoft about 2 years ago, and I wrote it down, and it always stuck in my mind that that's really what this business is about exploration, and it's about curiosity. And when companies like OSIsoft and, of course, Sas can help lower that cost of curiosity, that's when great things happen. There's a really interesting project going on in Christchurch, New Zealand. And you probably know they had just a horrendous earthquake, actually a series of earthquakes back in 2011, killed 185 people. And it destroyed about 70% of the central business district, and just absolute devastation. But they are, and it's going to take about $20 billion to rebuild Christchurch. And the cool thing is they intend to rebuild Christchurch as a sensing city. And their philosophy is sensor everything. And the time to put in sensors is when you're building, not afterwards. And unlike some other smart cities and these projects, this is a living, breathing city. And they're going to be doing this as they go along. But there's a really interesting piece of their philosophy that says measure everything, even if you don't know what you're going to do with it today, because someone's going to figure it out in the future. And what they intend to do is measure everything, put all this data out in publicly available data sets, and let people have at it. And let them develop applications, let them solve problems with it. It's a really exciting story. If you haven't heard about it, just Google Sensing City, and you'll absolutely love it.
Yeah, I mean, that's really, I mean, just that availability of the data and the opportunity for people to be able to explore it, I mean, really seems like it will open up a lot of opportunities. Now, I mean, jumping a little bit outside of the energy spectrum, something that's come up a lot today is that idea around smart cities and smart water and transportation. And Tim, you talked about there, measuring everything and, really figuring out what to do with that information. And I know for Matt, there are several, I mean, there are a lot of cities out there and communities that, I mean, they're really grappling with, okay, we're collecting this information, but how do we start to approach big data and analytics? What can some communities do to really help get a better grasp around all this information that's becoming available to them? And can that tie into some of their smart grid journeys that some of them are on?
Sure, I think that, there's a really good example that's just now starting here in North Carolina at the Chatham Park development. And we've had great engagement with the utilities, with the industry community, as well as some government, to try to make sure that is a smart city that comes off, with great benefit to the residents of Chatham Park and the city of Pittsboro. It's easier if it's not a retrofit. You know, that's kind of the bottom line. There's not a tremendous amount of infrastructure there right now, so as they're building out the environment, they can do things like put a lot of the sensors in place, measure everything everywhere. I think it's simpler to do. On a retrofit basis, some of our clients are understanding now that that there are some pretty significant interdependencies between key services like energy and water and gas. And those interdependencies are effectively events that can be tagged and measured and then correlated with one another to optimize each one of those subsystems. And that's what a lot of the smarter city environments are starting to do. We've got the benefit in Chatham Park of kind of starting with a somewhat blank whiteboard to make that happen. And we're looking forward to continued partnership with them and the RTCC in driving that value there.
What,
Matt, I wanted to add on something
ahead.
to Matt's comment. This is a great opportunity for the Research Triangle Cleantech Cluster in this entire region to participate in the build out of what is going to be the showcase smart community. I mean, this is more than it's not really a smart city, this is a smart community. It's taking place here. It's going to take 20 to 30 years to fully build out Chatham Park. But it's just been an absolute pleasure to see the RTCC companies engaging with the developers of Chatham Park to bring something out of the ground that is going to be the showcase smart community.
I'd like to put out one just comment. Whatever you're thinking on Chatham Park, you're underscoped. Because you tend to, not you per se, but the industry tends to think in terms of meters. And meters only take you halfway. We go beyond that meter, now you're in the homeowner systems. Now you have all the consumer appliances. You go to this side of the meter and you have distribution substations, and then you go to the internet, you have weather. So the best thing I think to do on infrastructure is just, you're right, it's easier if you don't have to retrofit. Just bury fiber everywhere and plan on it being 10 times what it was, because the process is not a one-time process. This is something that's going to go on. Every year you're going to come up with something else people will want to put in there. And I think of all the things I've seen, underscoping is probably the biggest issue.
So what about for communities that are, I mean, they're already there, and they already have streets and water networks and power lines and all of that. I mean, how do they start to approach this idea of a smart community and a smart city? I'm going to pick on you, Matt.
Sure. So it's difficult, quite frankly, to get the people aligned, to get the companies aligned. Mm-hmm. This actually isn't a technology issue at all. The technology is available, whether it's laying fiber in the ground or wireless technology, ubiquitous wireless technology, or the analytical horsepower behind the scenes, along with the computing power to be able to solve those problems. The real issue is getting policy and utility and services companies alignment to make that happen. So it's perhaps a little bit different answer than you were looking for, Christine, but ultimately if policy comes together and the utilities can align their objectives, the technology part, I don't want to oversimplify it, but that is a much easier problem to solve and usually a lot quicker to solve as well.
Yeah, I mean, I think in a lot of the work that I've done, I mean, there's definitely that technology piece, and getting it all to work together can be a challenge, but I mean, just people and the interactions they have and the policy and the regulatory environment that sets it up, I mean, can definitely, I mean, that has a huge influence on it.
Yeah, I'd add one more thing there, though, because I think, I agree, it's definitely, it's really not technology. It hasn't been for some time, but it is about economics. And if the underlying thing that you're trying to do has economic value, it ultimately will succeed in the regulatory environment, and it ultimately will succeed in the political environment, because at the end of the day, that's the only thing that carries the water. Is, you know, it doesn't matter what you think, no matter how passionate you are. If you can align those thoughts with the right economic model, you will be successful.
So, you know, jumping back to the energy industry a little bit more, you know, Tim, I mean, we've talked about a lot of different pieces here of big data and analytics. I mean, what should utilities be thinking about? What are some of the best practices out there for bringing together, you know, analytics resources and data resources within companies?
Yeah, so we see a couple really important trends in that area. One is that there's a general recognition that there are different buckets of analytics. There's enterprise analytics, and that can be things like planning and forecasting, and that's been a very big growth area for us as people see that the load forecasting problem, which used to be a solved problem, people would tell you 5 or 10 years ago, the problem became unsolved if there's a problem like that. So you can call that planning. The second big bucket we see is customer analytics or customer intelligence, and this is where it gets even more difficult, because now you're not dealing with electricity that is very complex but entirely predictable. And now you're dealing with people, and people are complex and they're unpredictable. And there are a lot of opportunities there. The third would be generally around, I would say, asset analytics. And what we see the leading companies doing is there's no one way to best organize your analytic resources. First, you have to go get them. And you've got to get the engineering students. You've got to get students to study engineering, and we talked about STEM earlier. And I think there was a mention of the 14 grand challenges of engineering. I don't go anywhere without my 14 grand challenges of engineering booklet, which I picked up at the early college high school at NC State. And students need to know that of the 14 grand challenges for engineering, 3 of them relate to energy. So you've got to get the pipeline of students studying STEM. You've got to get them to study energy. You've got to get them to come to the utility business, and then you have to organize them. And that may be in an analytics center of excellence. It may be a centralized pool of analytic resources that works across business units. It may be best where you deploy those analytic resources out in the business units. There's a lot of information out there to help companies on their analytic journey. Like I said, there's no one correct answer, but there are a lot of people who can come alongside and help with organizing and deploying those analytic resources.
Definitely. And I mean, I've been working on a course at the University of Denver where we talk about utility analytics and talk about all these challenges and really try to educate people and get them excited about the utility industry. And one topic that we've talked about in there that really, you know, I think surprised students, or they hadn't really thought about because they're so excited about wind power and solar power and all these things, is just the cybersecurity issues that come along with data and analytics. And I wanted to see if, and maybe each of you want to talk a little bit about, you know, what are some of the big challenges around the cybersecurity piece, and, you know, what does the industry need to be thinking about in terms of big data and analytics? Sal, do you want to take a moment?
You know, cybersecurity is absolutely an issue, and people being able to, you know, get in and terrorize a utility system is a concern, obviously. So NERC, SIPs, regulations, there are regulations that are in place to try to control that, to try to minimize intrusions into the system. And today, there are a lot of companies that will prevent you from even tying into their system. Mm-hmm. They won't do, for example, remote monitoring, because they're not comfortable that the people that have access to the data, someone else will come in and steal it and do things they shouldn't do with it. There's ways around that. I mean, at the end of the day, again, for us, I'm looking at power generating assets. And I'm looking at how do those assets operate, how are the demands on those assets changing. You know, we talked about, you know, the fact that we are getting to a more complex energy market requires large gas turbines to start up in 10 minutes. So having access to data for the equipment manufacturer especially It's the only way they're going to improve the product. So there's ways around that. There's ways around pulling the data, extracting the data through a automated data entry process where you're creating the history and you're sending that to the OEM. So they're not really tied in directly, or they're sending it to whoever they needs to see that data. There's ways around that, but it is a real issue that needs to be addressed. And I think the technology and the security, there's ways to protect. And for example, we access data from hundreds of power plants once per second. I could see a startup, I could see a shutdown, and we transform that data into time, capacity, and events. But you better be NERC CIPS compliant when you're doing that.
Just to add on to that, so Don Bowman mentioned that we host their data and some of their systems, and we do that for about 500 of our clients. So we've talked today a fair amount about cloud computing. If you were to go into our NOC, either here in North Carolina or in Boise, Idaho, which is the center of the universe if you live in Boise, Idaho, but one of the items on the display that you'll see is the actual the detecting of penetrations from or attacks from all over the world on a real-time basis. It's an analytical problem that we have to solve, and it's basically to assure our customers that we are actively monitoring all of these threats on a real-time basis so that we can ensure the integrity of your system. Because I used to work for one of the largest electric and gas utilities in North America, and our mission was to provide safe, reliable energy services. Well, if you start to compromise the safe and reliable, that gets a utility pretty worked up quickly.
I'll say one thing on security, because in a way, not being able to see something that you need to see is also a security issue. So it's not always possible just to cut off the access. But what we've seen is that we deal with a different data. We deal with on-prem systems a lot. Instrument systems, EMS systems, SCADA systems, and et cetera. They are generally computers that a hacker would recognize. They are generally unpatched. So the important thing is to keep them out of that space in the first place. So if you go look at the hardware, the way they've set up security at many of the ISOs, there's actually 2 or 3 layers of computers that are patched, because generally if you get into the IT environment, there are pretty good strategies for keeping out bad guys. Not totally, but pretty good. But if they get in that plant floor or back on the control bus, it's a script kiddie could get in. There's just nothing there that they couldn't see.
And what about, I know, Matt, you had mentioned cloud computing. Do you want to talk a little bit about that in terms of big data and analytics for utilities? I mean, what role is that going to play going forward?
Sure. I think that you heard a little bit about that earlier, where some of the smaller utilities who have the same operational problems to solve as the larger utilities will struggle with things like IT staffing. Ultimately, they can lean on the vendor community to, especially once we show them the processes we have in place to keep the bad guys out and make them comfortable with that. But also what we've seen is some of the larger utilities have a willingness to engage in the same way, because basically they're saying, I want the answer set. I want the result of the processing that happens behind the scene. I don't want to have to spend a lot of horsepower, internal manpower in managing those solutions. My time and money is better spent doing the analytics and dealing with the result sets and taking action operationally. So I think that those are some trends that we've seen, not just here in North America, but all around the world.
Yeah, I had gone to a municipal utility summit a couple months ago, and very, pretty small municipal utilities there, but I mean, they were excited about smart grid and data and analytics, and most of it was from, software as a service or, having that cloud computing capability, having that expertise come in. And Kevin, do you want to add anything around that?
Two things. One is, it used to be the case, probably still is a lot, that, as soon as you said cybersecurity in a room, you could clear the room, especially if you're in a DoD meeting. But, the reality is that we have to live with it. It's not, you can't stop doing things because you're concerned about it. And we introduced our first cloud product a couple of weeks ago at our conference, and for sure the infrastructure today is much better positioned to be able to provide that than it was even 5 years ago in terms of both the capabilities that are, but also that it is the reality. You're going to have to deal with, like I think it was the gentleman from Lowe's this morning said, nobody really likes the fact that Google can read our email, but we really like Gmail, so we'll live with that. And so there's a forward momentum that's not going to change that. So you do have to deal with it. And I would also argue that it's not even the bad guys that we think of. A long time ago, when I was doing some research on parasites, you learn pretty quickly that the best parasites are the ones that you don't know you've got. The ones that kill you, obviously, they don't have very good life strategy themselves. But the ones that can do that, like, the $3.4 billion fines that were levied against banks just 2 days ago. And when you can figure out how to manipulate the market, and, in fairness, if Enron had not gotten so greedy, they might have gone very well for a long time. But it's those are the ones that are the hard, but you know that's going to happen, and you know that you have to stay ahead of it and stay on top of it. But it's not worth locking the doors and pretending that I'm not going to be here, because the benefits far outweigh that.
Just one other thing.
Yeah.
For our clients, it's very important that they are able to share information. So if I'm operating a large frame 7F gas turbine in some city and I've got another user operating it across the country, they want to be able to they want to be able to share information that they're willing to share. And they want to be able to do that securely and without compromising, the fact that they want to share it between the two of them. That's an issue that we face all of the time. So cloud computing or access to data through dashboards, so it's analytics that they're looking at, comparative statistics, so that they can both make business decisions. And now they're looking at not just their unit, they're looking at a group of units to broaden the set of data, to broaden the statistical sample size, to make it more meaningful. And that's an important issue for our company today and hopefully into the future.
Just to add one thing, Christine, SAS has a very fast-growing area of our business called Sas Solutions on Demand, and when you did the campus tour with Dr. Goodnight, he may have pointed out his cloud computing building. It's the only building on SAS that you can't go into because it's so secure, but it's a big part of our business. We haven't seen a lot of uptake in it so far from energy companies, particularly because of privacy concerns, data concerns. But it's in fact, you also heard Dr. Goodnight talk about the building that just was opened a few weeks ago, the joke about the governor, and the people that are in that building, they all work on Sas Solutions on Demand. So we're seeing tremendous interest from other industry segments in not only cloud solutions, but also call it answers as a service.
All right, so we're going to open it up here for audience Q&A in just a moment. So be thinking of your question if you haven't already thought of one. But before we get to that, I wanted to ask each of you one last question here. We've talked about a lot of change that's happening in data and analytics within the energy industry. And I wanted to get a sense of, what do you think could be a big curveball for energy, big data and analytics in the next few years that our audience should be aware of? Something out there that could really change the game. And what if anything can we do to prepare for it? On Pat.
Well, just go to Europe. It's privacy. Like you say, well, we like Google email, but they read all our email. They not only own your email, they own the content, and they own the content of everybody you send the email to. And a lot of these new startups, they basically do a startup and it's free, and they take your data and they sell it to the marketers. So the privacy is coming on like a steamroller. And with these meters attached to somebody's house, I think that's going to be, ought to be addressed sooner rather than later.
Yeah, I guess I'll add on to that. The utilities, so it's already been kind of litigated who owns the data associated with the consumer. And it's ultimately the consumer's data that the utility has stewardship over. But what's happened is you've had some companies come in and disintermediate the utility. And to the extent that that starts to affect that relationship with the consumer and starts to affect reliability and the economics, to Kevin's point earlier of can the utility, make money off of their core asset management anymore? Once the economics start to shift against the utility, that's when I think the curveball could happen. I think that at the end of the day, utilities need to be incented on a policy basis to participate in that consumer relationship. And until they're really incented to do so, I'm afraid we're not going to get much uptake there.
And I'm going to just kind of build off Matt's point. I would say the biggest curveball would be a mismatch between regulatory policy and business models.
Kevin?
Yeah, probably, I would agree with that, although, as somebody who played a lot of baseball, I kind of specialized on curveball, so I'm it was the fastball that gave me trouble. Anyway, I think that's right. I think that the things are happening at a much faster pace right now than they've ever occurred in the industry, not because of things in the industry going on, because of things of outside the industry and people's expectations. And that impatience can lead to disconnects from regulatory business models. It can also lead to new opportunities. So I'm excited about it. I'm very confident that I don't know what it's going to look like. I just know that I'm excited to be along for the ride and be able to participate in it.
Yep. And I think there's a big bet being made on big data. And I think that in the near future, people are going to be looking for demonstrate the economic benefit of that process. Show me the money. Show me where I got the savings. If you look at the concept of the industrial internet, for example, the concept of 1% improvement, and that turns into billions of dollars of value. So I think the curveball is we don't get there. I think the curveball is we're not as fast as we need to be or as nimble as we need to be, and the sensors aren't as reliable as they need to be. And all you need to do is make a bad gamble once or twice, and you got a problem. And I think that's a potential issue.
During the entire day today, not one time did we hear a phrase that was in vogue about 20 years ago, which was artificial intelligence. Now, at the time, that was even a pretty contentious concept. And I remember a senior engineer told me at the time, he said, an engineer who depended upon artificial intelligence does so for the same reason a paraplegic depends upon artificial limbs. So you have to think about that now. So, so the question is, did it, with respect to all of this data, you think it'd be pretty valuable to divine the trends and the correlations and all that sort of stuff. So did it just not work at all, or is it called something else now, or what?
Maybe I can answer a little bit of that. When we were at Esri's user conference, Neil Jacobson from Singularity spoke on the use of AI in the business, and it's not my field, but I say it's flat scary. He shows a curve. As engineers, they trained us, everything's sitting on a curve. When it got to be like nothing, then it got to be a gnat's brain, and then it went up to whatever's next, bird brain. And the curve is smooth. Within 10 years, the artificial intelligence will be making the decisions, things that we just accept, like Watson winning in the game. It's going to be routine. So no, it's coming. Fortunately, we don't have to worry about that. We just keep pumping data to the monster.
I'm David Doctor, CEO of B4 Carolinas. I know you all are aware that the Department of Energy forecasts 25 years from now that 90% of our primary fuels are still going to be petroleum, oil, coal, natural gas, nuclear. So I see that energy analytics is focused primarily on the consuming side. I'm interested to know what you see happening on the production side, converting these various fuels to power. converting petroleum products to propulsion in our fleets. So where do you see energy data analytics impacting that to make that more efficient?
There's a fair amount of that actually goes on today inside the plants themselves in the generation units. And so I was a customer of OSIsoft for quite a while, and we would monitor different components inside the plant and then correlate each of the plant production across the entire portfolio. Where it gets trickier now is, as we heard earlier today, with distributed generation. And I wouldn't say that it's either a demand side or a production side. It's now a more complex ecosystem of portfolio that needs to be balanced with an active participant that's both the utility and the consumers. And we think about residential consumers in that regard, but large commercial and industrial consumers are, C&I customers are about 70% of the typical utility consumption. So they can play a large role in the efficiency or inefficiency of the generation portfolio. So again, I wouldn't necessarily classify it as either or. I think it's an ecosystem problem to solve that's increasingly complex.
I also got to mention something. I think that, you know, I know that DOE does that, and I know what they've predicted, but I also know that, you know, we were part of the Sunshot Initiative research, and part of what we did was using data and analytics to work with controllable inverters for PV, and, you know, the whole sole purpose was how do you get the traditional concerns about 15% penetration on a distribution circuit up and above that, and we got to 50-60%, and they've made enormous progress on that. So I think it's everything that we talked about, including the kind of pattern recognition stuff that Scott was just asking, has contributed to that, and it is still very dependent on a lot of data. There's a lot of real-time data. There's a lot of big data, both from a historical perspective and actual perspective. But it's all about being able to understand it better so that you can actually start adjusting things and take advantage of you're going to see a cloud in 5 minutes, and that's what you need to do in order to make it a well-behaved piece of generation equipment when it doesn't have a spinning mass. So.
I was just going to say that, you know, fossil fuels, gas, you know, especially gas, is going to play a very important role in our economy in terms of power generation. Also in terms of the use of gas for, you know, oil exploration, or, you know, on platforms using the gas for oil recovery. I mean, the bottom line is, in my lifetime, in my children's lifetime, we're going to have a dependence on fossil fuels. The OEMs today are building larger, if you just talk about gas turbines, larger gas turbines to get to 65% thermal efficiency. And so they need data. They're using data every day to drive product improvement, to understand, you know, what their actual performance needs to be and what kind of problems they're going to be running into. So data has an enormous value in the design activity that every one of these OEMs are taking. So I think that the reality is they're already in the use of data analytics, and it will have a tremendous value. Chevron, as both a utility and oil exploration company, spends a tremendous amount of time and effort making sure they're capturing data from all of their plants all over the world so they can understand the operational performance and they can drive down costs. So I think we're already there. We're at the beginning of there, maybe. But I think at the end of the day, there is a desire to have that data to make that 1% gain for productivity improvement. I think it's
great. Well, thank you very, very much. I've really enjoyed hearing from all of you. And let's thank Christine and the panel one more time. And what a terrific cavalcade of experts and stars we've had. So thank you very much.